Section 6.1b. First half of Section 6.1b is going to be word problems involving law of sines. Up until now, all the word problems that we have worked with have been with right triangles, so we've been able to use our right triangle trigonometry. Now we're going to be working with triangles that aren't necessarily right angles. Example 6. A pole tilts towards the sun at an 8-degree angle from the vertical and casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How long is the pole? So the first thing we need to do here is draw a picture representing what we have here in this problem. We have flat ground. We have the sun somewhere up in the sky. And we have a pole that is leaning toward the sun. What we're looking for is how tall or what is the length of that pole. Well, other information that we're given here. We know the angle of elevation to the top of the pole is 43 degrees. So this angle down here is 43. We know the shadow that is cast by the pole is 22 feet long. And we know the pole is leaning at an 8-degree angle toward the sun. So this angle down here is 8 degrees. From this, we're going to get a law of sines problem. If we begin setting up our ratio, we know that side x, which is what we're looking for, over the sine of 43 equals the side that's 22 feet long over the sine of, and we need to figure out what angle this is right here that is opposite that side that is 22. Well, in this case, because the blue dotted line I've drawn in here is perpendicular to the ground, we know that this angle right here is a right angle. Therefore, this entire angle here is 90 plus 8, or 98 degrees. We can subtract from 180 to find the missing angle. 180 minus 98 minus 93, and we see that that missing angle is 39 degrees. Solve this proportion, multiply by sine of 43, make sure you are in degree mode, and we get x to be 23.84 feet. Example number 7. The course for a race starts at point A and proceeds south 52 degrees to the west to point B, then south 40 degrees east to point C, and finally back to point A. Point C lies 8 kilometers directly south of point A. What is the length of the entire race course? Once again, we need to draw a picture representing the situations, things that we know right away. Point C lies 8 kilometers directly south of point A. So if point A is there, we know point C has to be directly south of it. And we know that that distance is 8 kilometers. From point A, we go south, rotating 52 degrees to the west. So our north-south line is right along this line that we've already drawn from A to C, since those C is due south of A. We have point A, and we are rotating 52 degrees to the west to get to point B. So that means we are going in this direction. Here's point B out here, and we know that we rotated 52 degrees. From point B, we go south. So again, we need our north-south line. This time 40 degrees to the east to get back to point C. So this angle right here is 40 degrees. Now we need to use some parallel line properties. Our north-south lines that are dotted in here in blue are parallel lines. So this 52-degree angle right here and this angle right here are alternate interior. Those are equal angles. So that's also 52 degrees up there. And I know that this angle plus this angle plus this angle all lie on a straight line, so they have to add up to 180. So if I take 180 minus 40 minus 52, we find that this angle right here is 88 degrees. Now in the entire blue triangle here, we have 88 plus 52. Subtract that from 150. We find that that angle down here is 40 degrees. So now we need to find the two missing sides. Let's call it side C, since it's opposite angle C. And let's call this side A since it's opposite angle A. Find those two measures, add A plus C plus 8, and you will have the entire length of the race course. So the first one we're going to find is A. A over the sine of 52 equals, the ratio we know is 8 over the sine of 88. Multiply by the sine of 52, and we find that side A is 6.308. Do the same thing now, and let's find side C. So we have C over the sine of 40 equals 8 over the sine of 88. Multiply by the sine of 40, and we see that side C is 5.145. We're looking for the entire length, so we need to add up all three of these sides. So I'm going to take 8 plus 5.145 plus 6.308, and the total length of this race course is 19.453 kilometers. Last thing in section 6.1b here is a special formula we have for finding area of triangles. Anytime that you are given two sides and an included angle in a triangle, you can use this formula to find the area. 1/2 AB times the sine of C. Only when you are given two sides in the included angle. So what does that mean? Well, if I draw a picture in terms of what the formula is here, and I have triangle A, B, C, so that means this is side A, this is side B, and this is side C. The included angle has to be the angle that is formed by the two sides that you are given. So in this case, the way this formula is written, the two sides are A and B. Well, if I look at side A here and side B here, the angle in between those two sides is that angle right there. That is the included angle. So any two sides along with the included angle, and we can use this formula. Notice that that doesn't mean that it has to necessarily be sides A, B, and C. As long as you have side AB along with angle C, you can use this formula. We could also write this as 1/2 BC. Now the included angle between sides B and C would be angle A, or I could have sides A and C that I know, and the included angle would be sine of B. So there's really three different forms, but it doesn't matter what you call A, what you call B, and what you call C, as long as you have sides across from angles labeled the same. We can be given any two sides along with the included angle, and we can find the area using this formula. So looking at one example here. Find the area of a triangle having two sides of length 90 and 52 with an included angle measuring 102. So drawing a quick sketch of what we have here. We have an angle of 102 degrees that is included between these two sides that are 90 meters and 52 meters. Only other formula you know for finding the area of a triangle is 1/2 base times height. You must know the base and you must know the height of the triangle. Well, in this case, the base is 90. The height, though, would actually be this distance right out here, so that that's a right angle. So we would have to go and calculate that in order to find the area of this triangle. Since we are given two sides in the included angle, though, we can go right to our formula. Area equals 1/2 the two sides that we are given, 52 and 90, times the sine of the included angle, which is 102. Simply plug all that into your calculator, and we get an area of 2,288.87 square meters.